Hello and welcome. In today's lesson, we're going to discuss further about transformation. In the last lesson, we talked about what we mean by transformation and the basic concepts of it. And in this one, we're going to talk about the different kinds of transformation and how to apply them. Now, if I have to put all the transformation in one lesson, it would take a long time. So I'm going to break it down and put each transformation in each lessons so that it becomes more simple and easy for you guys to understand. So as you can see, I've listed down all the transformations that we're going to deal with. We have A, which is a vertical stretch, compression, or reflection. We have K, horizontal stretch, compression, or reflection. D is horizontal translation, that is moving left or right. And then there is C, which is vertical translation, that is moving up or down. In this lesson, we're just going to deal with A, which is vertical stretch, compression, or reflection. Now, in different curriculums and different countries, they might use different variables to represent the transformations, but generally, it basically means the same thing. Let's start with this function f of x. And we're going to define the function f of x as x squared, a quadratic parent function. Now, anywhere you see f of x, that means we're going to define x squared. So the first thing that we need to know is how does a transformed function look? Now, since we are only going to deal with A, I'm just going to show the A transformation in a function. I'm not going to show and confuse you guys altogether, which by the way, we're going to learn in a later lesson. But in this lesson, let's just concentrate on A. So the transformation A usually is shown in a function like this. Let's say the function is y equals to A times f of x. So any number that you see on the outside of the function that is being multiplied is basically our A value. So whenever we see a function, it is important that we identify this transformation right away. So I'll give you a few examples how it looks like for different kinds of function. So let's take a quadratic function. And the transformation A would look something like this. Y equals to A x squared. Or if I have to talk about a square root function, the function would look like y equals to A square root x. If I have to talk about a reciprocal function, it will look like A over x. So they basically mean the same thing. It's just that different functions are written in different ways, and that's why the A is written in different places. So let's move on and explore the vertical stretch, compression, and reflection a little bit more. So as I explained, we're going to use the function y equals to x squared. And the value of A would be outside the function. So let's take the value of A to be 2x squared. Now, whenever you have a function like this and you have identified the value of A, let's say I ask you to apply this transformation on the ordered pair 1, 2. So there are a couple of things that you guys need to know. So the A transformation is always applied on the y values. And another thing that you guys need to keep in mind is how it is being applied. So we apply it by multiplying to the y value, multiplying to the y values. So if we have an ordered pair over here, 1, 2, and we apply the transformation a equals to 2, so this is only going to affect the y value of the ordered pair. So my new ordered pair will be transformed into 1, comma, 2 times 2 is 4. And the x value will be unchanged. So that's how you apply the A transformation. That is a vertical, stretch, compression, or reflection. Now, if we think about it like this, that we are multiplying a number with the y value, so it will obviously affect the vertical axis, which is the y-axis, and that's how you can remember that we're talking about a vertical stretch, compression, or reflection. Now, when we apply the A transformation, we can either have a stretch, compression, or reflection. How do we know that? So let's take a value of A that is greater than 1. Now, if we multiply any number that is greater than 1 to another number, that number will always grow. So like that, we know that it is a stretch. All right, so if A is between 0 to 1, and we multiply a number between 0 to 1 to another number, that is, let's say we take A equals to half. If we multiply half to another number, that number will be halved. So that number will be compressed. So that's how we know that when A is between 0 to 1, we call it a compression. And last but not least, when A is less than 0, that is, A is a negative number, and when we multiply a negative number to another number, that number turns negative as well. So that makes it a reflection. So this is something that you need to remember when you were doing transformation. So that's pretty much it about vertical, stretch, compression, or reflection. Now, I have shown you an example using an ordered pair over here, but I'm going to show how a transformed graph could look like. So here are a few examples. So if we take a look at the graph on the left, we can see that the parent function is f of x, and that is in blue. And if we apply a transformation of 2, we can see a vertical stretch that is shown with the green dotted line. And if we apply a transformation of 0.5, we can see a vertical compression that is shown using the yellow dotted lines. And if we move on to the graph on the right, we can see that the parent function is on blue, which is f of x equals to x to the power 5. And if we apply the transformation of -1 over here, we can get the red graph, which is a complete reflection on the x-axis. So that's pretty much it that you guys need to know. You guys need to know how to identify the value of A. You guys also need to know the different values of A that will give you a stretch, compression, and reflection. And you guys also have to remember how the transformation is applied. So thank you so much. I know this might seem a little overwhelming, but once you practice a lot, you will get used to this. So I have provided a bunch of practice questions for you guys, and also to challenge yourself, you guys can try out the quiz and see where you stand. Good luck, and I'll see you in the next lesson.